Hello people, welcome to another video where we will look at again double point charges inside, and also we're going to stare at the electric field between these 2 point charges. So let's go. Right, this question is from March 17, paper 4. State one similarity and one differences between electric field lines and gravitational field lines. So you should have already know that they are pretty much identical pillars when it comes to analyzing the fields, but there are actually also a lot of difference. Like for example, the gravitational field is only attractive, and the electric field can be attractive or repulsive depending on the polarity of the charges. So let us begin. So similarity, if you think about the um, actual scenario, or if you think about the way we draw the electric field lines, the similarities will be you will draw them, like the diagram. You see, isolated positively charged metal sphere. All right. So for a gravitational field, the field lines, let's say this is the G field. Okay. The field lines, we will draw them radial as if they pass through the center of the sphere. Right, here is a better drawing. So the gravitational field lines are always pointing inwards because gravitational field is an attractive field. Okay, so this is the shape or the pattern. All pointing inwards along the radius. Okay. Whereas for a positively charged metal sphere, the word positive here. So if this is positive, right, it will still be radial, but the direction will be pointing outwards, because when we define electric field, it is the direction of force on a unit positive test charge. Okay, there is no repulsive gravitational field, but there could be a repulsive electric field, like for example, this positive charge. Okay, so we're going to write both of the similarities and differences now in a simple sentence because it's just 1 mark each. Similarities, you can say that the field lines, we need to describe the lines. So the field lines are radial. Okay, pretty good enough. Or you could say that the separation of lines, because as you travel away from the center, the lines are further apart. So you could say greater separation of lines with greater distance. Right? So greater line separation with greater increasing distance from the center of the sphere. Right? But radial lines are easier to write like in a sentence. Okay, what are the differences? One, the lines are pointing inwards for gravitational field, and the lines are pointed away from the center for the electric field. Okay, so you need to write about both. You cannot just point out gravitational field and then call it a day. Okay, because similarities, you can only write you only need to write the similarities once, because this is for both fields. Whereas for the same, you see these two are the same sphere. Okay, these two are the same sphere, but the gravitational field and the electric field, although they have the same pattern, right? What will happen is that so I'm gonna hang on. Okay, so this is the gravitational field pattern. The patterns are the same, so you only need to state once. But the direction of the electric field is different. So you need to state 2 times. So you need to describe gravitational field lines are pointing inwards, but the electric field lines are pointed outwards. All right, so there you go. Gravitational field lines directed inwards towards the center of the sphere, and electric field lines away from. So make sure your phrasing is correct. This is about direction towards, directed away. Okay, next part B. A positive point charge plus Q is positioned at a fixed point X. So we're going to put positive Q at point X here. And the identical positive point charge is positioned at point Y here. Or I. A and B are not charges, they are just arbitrary points. Charges are separated with a distance of 10 cm. So pretty familiar setup. But today, instead of point charge A and B, they go and put point charge X and Y. Sure. So points A and B are on the line XY. Point A is 2.5 cm from X and point B is 2.5 cm from Y. Electric field strength at A, so electric field strength at A is 4.1 times 10 to the power negative 5 volt per meter. Calculate the charge plus Q. Okay, so this question is a little bit different. You're not given a graph, but you're given values. So to find the value of positive Q, I guess we gotta do a bit of vectoring or think about vectors. So let's consider the direction of electric field. Positive charge, electric field will point outwards. So EA will point in this direction. We are closer, sorry, not EA, EX, the electric field due to the point charge at X. So EX will point away from charge X. Okay, and just like charge Y is also positive, so EY will point away from charge Y, but EY is smaller than EX. Means how you know further away. The charge is the same magnitude. Further away, you get a weaker field. So I can safely say that the electric field strength, they are vectors and they're in opposite direction. So I can say that the resultant electric field strength at A, which I will call EA, so say EA is equal to the electric field strength of X plus the electric field strength of Y. So this is again, I don't know how many times I've mentioned this in all the previous videos as well, that it is important for us to remember that your electric field strength is a vector. So when it comes to vector, we have to consider the polarity, all right? Meaning somebody here has to be a negative. And I think I'll just give EY a negative because it's pointed to the left. So the electric field strength at A will be equal to EX plus negative EY. All right, so all of this, just so you know, are vectors. So right now, we can now substitute values. Okay, we know what EA is, 4.1 times 10 to the power of negative 5. EX will be K, Q over the distance of X to A square plus K, Q over the distance from Y to A square. But this one has a negative sign, so it's minus. All right, so now we can substitute the values. 4.1 times 10 to the power of negative 5. K and Q is a common factor, so I'm just going to factorize it out. Okay, so 9.88 times 10 to the power of negative 10 to the power 9, sorry, times Q. Don't forget we're looking for Q over 1 over the distance from X to A. Let me see. X to A is 2.5 cm. Y to A will be, this whole thing is 10 cm, right? So this is 7.5 cm. Okay, so AX is 1 over 2.5 cm plus negative 1 over YA is 7.5. Don't forget the square. Means have to convert the cm. Correct, we have to convert the cm. Wow, so sneaky. Yeah, you study A level liao. All this conversion should be second nature by now. Whenever we involve a constant, look, my general advice is if you have not done enough questions or you don't have time to do questions, then always convert to SI. But whenever, my rule of thumb is whenever there is a constant or whenever your unit is SI. Like for example, this 8.99 is a constant. So whenever you invite a VIP into the equation, like a constant, everything in this equation has to be in SI. Furthermore, you see this volt per meter, you can always check the unit. So this one has to be in meter. So here we have cm square, right? So we're going to convert the cm square and bring it out because this is at the denominator. So here you will write 10 to the power of negative 2 for cm, but you square, so times 10 to the power of negative 2 square. Okay, so this is a method that you can shift out the prefix. Okay, and I hear your feedback. So for those of you who are not so good at dealing with prefix, it's okay. We're all on a learning journey, I guess. I will write this for you. But those of you who already okay one, press your calculator. Don't wait for me. All right, so those of you who are not okay, there we go. So what we can do is we can just put like that long 2.5 times 10 to the power negative 2 bracket negative 2 bracket square, okay, minus 1 over 7.5 times 10 to the power negative 2 bracket square. Okay, is that good enough for you, my friends? So the negative 2 here and negative 2 here. Now you can press your calculator to find Q. So whichever lah. So you can see what I did was I factorized out the negative 2. This one. This negative 2, the negative 2. I take and put outside so it's easy to press the calculator. I guess you would do this if you're good with conversions. Okay, so this is a technique so that because when you press calculator, you have to mind your brackets, especially for this one. You have to make sure when you square the prefix. And sometimes people just forget. All right, so this is just to safeguard you. So yeah, I press my calculator now. Okay, so after bringing all of these like big numbers together, okay, I will get this number 4.56 times 10 to the power negative 19. And now I can now deal with whatever that is inside the fraction and bring over to divide. All right, and after doing so, I will get a number like 3.21 times 10 to the power of negative 18 coulomb. Okay, so again, just a reminder, I don't know what calculator you're using. I'm using a pretty cheap and older Casio calculator. So make sure you know how to bracket properly. If not, you might have calculation errors here. Okay, so this entire thing is 3 marks. If you use, okay, so here's the thing. In order for you to get your first mark, they need to see, I'm going to write here for you, E is equal to Q over 4 pi epsilon naught r square. The thing is, it is not shown here. If you want to get mark for KQ over r square, then the K has to be substituted. All right. So for you to get that mark, I see the KQ over r square expression here. And then I see the K being substituted here. This 2 is my 1 mark. So this equation and the substitution of K is my first mark. You substitute wrongly, sorry, game over. So if you want to really play it safe, write this equation. CIE prefer this equation rather than the one with K. I like to use K because less things to write. You know, constant, easy, remember. 899 times 9, 10 to the power 9. So very nice. Okay, next. Second mark is when you actually substitute everything correctly. So correctly meaning I see this. I see the conversion happening and I see the right substitution. So all this substitution is 1 mark. So everything from this to this conversion, either you convert inside, like what I showed here, an alternative here to here, here and here, or you convert outside like me, whichever as long as you got convert and substitution correct. It's the 1 mark. And of course, the final answer would be the last mark. All right. So that is this part of the question. You are given a value and you're expected to know that because both charges have the same magnitude, the electric field will be pointing in a different direction in between both charges. Okay, so sorry, not same magnitude, same polarity. The electric field must be pointing in opposite direction. Same polarity, opposite direction. That's why we have to minus the field. So if you are very scared, oh, I forget this, I forget that, always draw your vector diagram. Isn't that the common advice when you do your AX? Draw your vectors so you know what to plus and what to minus and you're not confused. Means they are both same polarity. Why is there a minus here? Okay, so the minus is for direction, not for polarity when it comes to vectors. All right. All right, so we're gonna soldier on. Okay, so here is part 2. On figure 6.2, sketch the variation of electric field. This one got the trick one. With distance d from A to B along the line AB. Okay, so here's a question guys. You see Your D is only until 5 cm. Does that make sense? Let's think of it. You might be thinking, but miss, the charge are separated by 10 cm. You see this 10? Why can it be 5 cm? Well, distance D from A to B, oh, schnaps. They want you to draw here. So we don't care about X to A, we don't care about B to Y, we just want the middle portion. That's why it's 5 cm lah, okay? So we know here your electric field strength is 0, all right? And how do we know? Well, both point charges have the same magnitude. Oops, what's wrong with my OneNote? The lag is severe. Okay, so here you have the same magnitude, and at the middle, they have the same separation. So because both fields are in opposite direction, effectively they cancel out. So this means here is your E equal to 0. You cut through the midpoint here. Okay. Second thing is I know what is the electric field strength at A is 4.1. So I'm going to start with 4.1. This is paper 4, so we can plot in between boxes. In fact, I think you should or you must plot in between boxes. So I'm going to plot at 4.1. Okay, so we're going to go from 4.1 to 0. 4.1 to 0. Then when it's at 5, it will be also 4.1, but in the opposite direction. You might be thinking, Miss, how you know? Well, you see, if you look at the calculation here, let's think about point B. Wouldn't you substitute the same values for point B? The only difference is now, instead of 1.1 over 2.5 plus negative 1 over 7.5 square, you will take 1 over 7.5 square plus negative 1 over 2.5 square. Okay, so the equations, hopefully by now you should be familiar, that now if you take at point B, you are going to take 7.5 as A and 2.5 as, 7.5 as X. So this EX is weaker, EX. And EY is stronger. Here, EY, because it's closer. So this one should be negative, but it will have the same magnitude because everything else about the two charges are the same, meaning the magnitude should be the same. Okay, so we're going to flip it from 4.1 at 5 cm to negative 4.1. So negative 4.1 is somewhere here. So the shape of the graph should look like this. Okay, here the gradient is minimum, but not 0. Not 0. All right. So I'm gonna try to carefully join this here. And here we will intersect and try to maintain the symmetry such that this one would be here. Just try your best lah. But make sure you don't have broken lines like me lor. So this one need to do a bit of touch up. Okay. And then I will join them together. Something like this. Hopefully your graph looks good. Alright, so where do you think the 2 marks will come from? Of course, the marks are, okay, let me crop the mark scheme. Alright, here's the mark scheme, and you can see the term smooth curve. So reasonably smooth based on the judgment of the examiner, okay, and gradient decreasing, so it should be a decreasing gradient to the d-axis at 2.50, which is this point. So this part here would be the first mark. Smooth curve with gradient increasing and ending at the symmetrical point. This would be the second mark. If there is 3 marks, I would award mark for the fact that here the gradient cannot be 0. In fact, most examiners can subtract 1 mark if they feel that your shape is not nice, because this smooth curve here is up to, like for example, I don't think this is very smooth, especially if you're drawing this in the exam on paper. But on the tablet, I guess it would suffice. Alright, so that's part 2. Let's look at the final part, which is part 3. A small positive charge is placed at A. Electric field causes this charge to move from rest, okay, along the line AB. Describe the acceleration of the charge as it moves from A to B. All right, let's think about the acceleration. Okay, so this one is pretty similar to a question that I've discussed in another video. But the idea here is that the acceleration is directly proportional to force. Why? Because F is equal to ma. So I think I will write out that point first. So F is equal to ma, and for electric force, F is equal to QE. So hence, ma is equal to QE. Mass and charge will be the same. So because of this, A is proportional to E. So how does E change? Let's see. E decreases until 0 at the midpoint and increases in the opposite direction. Okay, so I would say that from A, let's think about the curve. It decreases, the value of E decreases at a decreasing rate. So from A, the acceleration decreases at a decreasing rate. Just to be safe, write the rate if it's very clear. Decreasing rate. Okay, until 0 at the midpoint between AB. Okay, then acceleration increases. Is this good enough if you just say increases? Nope. At an increasing rate. But even more importantly, you should say in the opposite direction. Because unlike some past year questions where they ask you to describe the magnitude, this one talks about acceleration. So when we describe a vector, think about all you have learned in kinematics chapter 3 AS. We need to talk about both magnitude, which here you can see acceleration decreases at a decreasing rate, 0 at midpoint increases at an increasing rate. So this is magnitude. And direction. Vector ma? This is a vector. Okay, so unless the question is very explicit, describe the changes in magnitude of the acceleration. Then you don't have to write about direction. So the direction is opposite direction. Okay, so for you to get marks, you actually have to cover a lot of points. Let me show you the mark scheme. Okay, if you examine this mark scheme, right, and by the way, right, their mark scheme is not consistent one. So it is assumed that you would write a full, complete description, regardless whether you are given 2 marks or 3 marks or 4 marks. Okay, do enough past year questions, you will know what I mean. All right, so here they clump together the idea that the acceleration must decrease to 0 at midpoint. Sometimes the examiner, it depends on the examiner, they will only award this mark if you have these 2 points. Some of them will award the mark because this is in bracket. In bracket, it's like a suggestion up to the examiner to follow. So this is 1 mark, which I already mentioned here. Acceleration decreases. I'm feeling insecure, so I said at a decreasing rate until 0. So this is 1 mark. Okay, and then the acceleration then increases in the opposite direction. So this part here is your 2nd mark. Acceleration increases in the opposite direction, or I guess you could say increasing rate. But you have to talk about the negative. This is the 2nd mark. All right. So generally, right, whatever information that is relevant, just to be safe, you should include in the description of the question. Sometimes it's 2, sometimes it's 3, sometimes it's 4. So always take time to analyze, figure out what they want from you. Like for example, in this question, they want acceleration, and because it's a vector, you should talk about the direction. All right. If sometimes the certain question only asks about magnitude, then you don't have to talk about direction. Okay, so please answer the question, underline, read. All right, and do more questions to level up your EXP. Okay, so do share this video with your friends if you find this useful. If you find it useful, and I will see you in the next one. Like and subscribe, and Thanks for watching. Bye bye.